Impossible galaxies push the boundaries of the universe. The James Webb Space Telescope has discovered galaxies from the universe's infancy that shine so brightly it defies possibility. Astronomers are seeking answers, as the cosmic creation narrative may need to be completely rewritten. Over 5 days, the world's largest space telescope, James Webb, focused on a small patch of the sky. The result: an image revealing thousands of galaxies. Many of them are spiral galaxies resembling our own Milky Way, but astronomers aren't particularly interested in those. Instead, their attention is on a small red cluster known as JWST Z1490, the farthest galaxy ever observed. The light we see from it comes from a very early stage of the universe, earlier than we've ever been able to study before. But what truly captivates astronomers is how intensely it shines. At first, astronomers couldn't believe their eyes, as the galaxy's brightness shouldn't be possible. It defies all established theories about the universe's origins, prompting experts to search for an explanation. And they already have some startling hypotheses, ones that could upend our understanding of how the universe began. Galaxies emerged at the dawn of time. The first galaxies were born during what astronomers call the cosmic dawn, around 380,000 years after the Big Bang. The first hydrogen and helium atoms gathered into massive gas clouds, which occasionally collapsed under their own gravity. This led to the formation of the first stars and tiny, fragile galaxies. These newborn galaxies could grow by drawing in more gas to form additional stars or merging with other early galaxies. According to prevailing theory, this process took time, around 1 billion years for some galaxies to reach the size of the Milky Way. Thus, astronomers expected to see only very small galaxies when studying light from the young universe, which they can now do using the James Webb Telescope. The telescope is specially designed to capture light that has traveled for billions of years, originating from the earliest stages of the universe. But when scientists analyzed images of JWST Z1490 in spring 2024, they didn't find the faint, dim galaxies they expected. The light from the galaxy has traveled 13.5 billion years, from a time when the universe was only 290 million years old. At this stage, astronomers expected to see young, faint galaxies. Instead, JWST Z1490 appeared more like something from a mature, much older galaxy. Based on its brightness, astronomers calculated that JWST Z1490 must contain around 500 million stars and span 1,700 light-years. Light travels for billions of years. The light from a galaxy weakens as it travels to us, meaning there's a difference between its observed and actual brightness. Astronomers estimate a galaxy's true brightness using 2 factors: how far away it is and how much light reaches us. Both can be measured using the James Webb Telescope. Brightness decreases with the square of the distance. By correcting for the universe's expansion, researchers estimate that the light from the earliest galaxies, including JWST Z1490, has traveled 13.5 billion years, but now comes from a location nearly 34 billion light-years away. For comparison, the Milky Way contains hundreds of billions of stars and spans 100,000 light-years. Yet JWST Z1490 reached its size in less than 300 million years, while the Milky Way has had 13.8 billion years to grow, nearly 50 times longer. This challenges the standard theory of galaxy formation, which cannot explain the brightness of JWST Z1490. Since then, astronomers have found other surprisingly large galaxies from when the universe was only 500 to 700 million years old. This has spurred a flurry of research to find possible explanations, one involving millions of supernovas. Did stars form in bursts? A key question is whether these surprising images of bright galaxies demand a completely new foundational theory of early cosmic development, or whether the brightness is an optical illusion. Some experts have debated whether they are being deceived by black holes. When large amounts of gas fall into a black hole, the gas heats up and glows intensely. A small galaxy with a massive black hole at its center could shine as brightly as a larger galaxy with billions of stars. But if this were the case, most of the light would originate from the galaxy's center, where the black hole resides. However, the light from JWST Z1490 and similar early galaxies is evenly distributed, suggesting a different explanation. One new hypothesis is that more massive stars formed in the early universe than today. If so, early galaxies shine so brightly because their stars are larger and brighter than those in the Milky Way, not because they contain more stars than expected. Another theory posits that early galaxies didn't form stars at a steady rate, like the Milky Way, but in intense bursts triggered by millions of supernovas. If true, the peculiar galaxies captured by the Webb telescope might represent moments when these bursts peaked. Researchers theorize that galaxies in the early universe formed stars in explosive waves. This would cause small young galaxies to shine so brightly that they appear in images to resemble much larger galaxies like the Milky Way. 1. Gas clouds form stars. In the early universe, a gas cloud collapses, creating the first stars. After a few million years, the largest stars explode as supernovas, causing other parts of the gas cloud to collapse and form more stars. 2. Supernovas expel gas. Explosions from the second generation of stars blow out much of the galaxy's gas, temporarily halting star formation due to insufficient gas. 3. Stars shine intensely. The galaxy's gravity pulls the gas back in, creating a high concentration of gas. This triggers the rapid formation of many stars, causing the galaxy to shine intensely for a few million years, a phenomenon captured by the Webb telescope. 4. The galaxy stabilizes. After about 1 billion years, the galaxy grows large enough and its gravity strong enough that supernova explosions can no longer expel its gas. The galaxy then forms stars at a slower, steadier rate. With current data, it's impossible to determine which theory is correct. However, astronomers are planning new observations with the Webb telescope. They aim to focus on these mysterious galaxies for longer periods to gather more information. We can likely expect more groundbreaking data from the Webb telescope, data that will keep astronomers busy for years to come. Ultimately, the unexpected behavior of stars in these early galaxies may not be the root of the mystery. It could be that cosmology itself, the foundational theory of the universe's development and composition, needs revision. Physicists may need to rethink how mysterious dark matter influenced the formation of the first galaxies with its gravitational effects. Regardless of which theories prove correct, one thing is clear: the universe's infancy was far more unruly than we ever imagined.